Hey guys, welcome back to Consistent Code. So today's problem of the day is composite and prime. So we are given an input as two integers, capital N, cap L and R, which are the limits left to right, and we need to find the number of that is the number of prime numbers between L to R, and both are inclusive. And what we need to return, we need to return the difference between the number of composite numbers present between 4 and 6 and the number of prime numbers present between 4 and 6. For example, in this case, from 4 to 6, I can say that the number of composite number will be 4 and 6, and the prime numbers will be only 5. So I can say the difference will be equals to 2 minus 1, which is equals to 1. So in the output we are getting 1. Great. So that's how we need to do this question. So how to do that? First we need to look at the constraints. We can see that r cannot be greater than 10 to the power 5. So that means that we can just create a vector to store or to check if that number is prime. We can give the range as 1 5 plus 1 to store 10 to the power 5 numbers to see if the number is prime or not. Initially, let us consider that all of the numbers are prime. Now, we need to say that 0 is not prime and 1 is also not prime. So we are gonna start with number 2, and we need to mark all the multiples of 2 as not prime, or you can say composite numbers. So here I can say that for I can start with int I equals to 4, and I should be less than equal to r, and I plus plus I plus equals to 2. I need to mark all of these numbers as not prime. Now, all the even numbers have been marked not prime, so we need to consider only the odd numbers if they are prime or not. So now we need to start from int I equals to 3, and we need to iterate it till uh, in fact we need to do it in O of root n complexity to be more efficient. So we can just iterate till capital R, and what we want that I plus should be equals to 2. So we are iterating over all the odd numbers. And why am I choosing I square less than equals to R? The reason is because suppose the number capital R is 25, then you can see that its factors are 5 and 5 only, which is the square root of 25. Similarly, you can see another number, let's say r is 100. So if you start from 2, then you can have 2, 5 and 10. You will not find any factor after 10 for this 100. So we need to only iterate till the square root of r. So if we can say I square is r, that also means that I is being iterated only till square root of r. So now we can just start iterating for all the multiples of. First we need to check if this I, for example we are at 3 currently. If the I is prime, then we need to mark all the multiples of this prime number as composite number. So we can just start with int j equals to 2, and we need to do this until our I into j is less than or equals to r, and j should be incremented by, in fact this j should be 3 because all the even numbers have been marked, so j plus should be equals to 2, and we need to mark is prime of I into j as false, right? So now when this loop will be over, in R is prime vector, we should be getting till from 2 to R, we should be getting if the number is prime or the number is not prime. So now what we need to do, we need to create a variable to store the prime count, a number of integers which are prime in the range L to R. And also, what are we having in this is prime, we will be storing the number from 2 to R which are prime. So definitely L to R will be subset of 2 to R, right? So we can start iterating from, so we can just start a loop from I equals to L, and I should go for till R, we should do a increment of I, and if it if that number is a prime, then we can say prime count incremented by 1, and finally we can return the difference of, in fact the absolute difference of the composite and prime numbers. So what will be the composite numbers? The composite number will be the total minus prime numbers. So the total numbers are capital R minus capital L plus 1. These are total numbers. We should subtract the number of prime number from them. So these will be the composite number, and we need the difference of composite and prime. So we need to subtract this prime count again. So I can just mark this as minus 2 times of prime count, right? So this should do the job for us. So if I compile and run this code and see if this is working for the sample cases, so this is working for this case. Let's try for example 2 also. So for example 2, we are having L as 4 and R as 4. So let's try it out. So it's working for this case also. So let's submit it now. Because we are getting a wrong answer. Okay, so the problem is when our lower limit is 1, because L equals to 1, that means 1 is neither a prime number nor a composite number. So initially we need to put a condition here that if L is 1, we need to increment L by 1, because we don't care if L is 1, we need to start with 2 only, right? So now let's try compiling and running it once again. So if the L and R are 1 and 1, so in that case it should be 0. There is no composite number, there is no prime number, and hence it should work. So now let's fix the sample example test case once again, and let's check this once more. If this is working, then we will submit. So now let's submit the code. Okay, so it's wrong again. So actually we should not be taking this absolute value, it should be only this value. So if I copy this input and try this out now and compile and run it again, then I believe we should be getting the output which is expected. So let's submit this once again and see if this is working. And we solved the problem successfully. So I hope you liked the explanation, and if you did so, make sure you hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.